Hey guys, it's Mr. Sameda. I'm sorry, my daughter's not feeling well today, so I have to take her to the doctor. So I'm not going to be here. I didn't know, and she was feeling bad this weekend, but I didn't know if it was going to be bad until this morning. So I got a short video with problems. It's nothing that's going to be too big. You're going to need to solve the problems that are in the packet. I think they're on pages 19 through 22. They're the free fall problems. You'll find them no trouble. I'll just go over some stuff real quick, and we'll do a couple sample problems together in the video. If you need to view the video again, it's on YouTube. The link will be on the board. We're going to talk about free fall. Basically, when stuff falls, the earth pulls it down because it has mass. By the way, this is the part where you're supposed to be taking notes. Okay. Its mass causes a gravitational force. Gravity is not separate from the mass of the earth. If the earth had no mass, there would be no force. Now, as long as you're close to the earth, which we're going to be, okay, as you get farther away, from the earth, the mass has less effect, which makes the Earth's gravitational pull decreases. But even if we get pretty far away from the Earth, like say in an airplane or something like that, we're still going to have roughly the same pull. It's going to be pretty close, though. For our purposes, the pull is constant. And what that means is that if the pull is constant, that means that the acceleration is constant. So the Earth's pull causes a constant downward acceleration, which is pretty easy to understand. I mean, in fact, I think you all know what it is. Okay. The amount is equal to 9.8 meters per second squared. And it's downward. Normally, I define everything on an XY scale, where Y is the vertical. And what that means for us is that downward means negative Y. And so I'm going to say that the acceleration due to gravity, also called G, is negative 9.8 meters per second squared. Again, the negative doesn't mean that it slows down, it just means downward. Let's talk about what that means for something that is dropped from rest. And we'll talk about what it means for something that is on its way upward, like a ball thrown upward. Sorry. This one I gotta do away with. So if it's dropped from rest, that means that, let's say that at 0 time, we have fallen, velocity. We're at 0 meters per second. And this is in seconds. 1 second later, we're at negative 9.8 meters per second. After 2 seconds, we're at negative 19.6 meters per second. All it means is that every second our speed changes 9.8 meters per second. Okay. In this case, it increases. Now, if something is, say, thrown upward, it becomes more complicated. Okay. We're going to say the initial speed is, I don't know, 25 meters per second. So in this case, it's going to change. It's still going to change its speed by 9.8 meters per second, but it's going to actually slow down until it reaches 0. Sorry, let's make this 30. Or 29.4 probably is better. Okay, just so we end up even. Now, at 0 seconds, we're at 29.4 meters per second, which is pretty fast. I mean, it's like 60 or 70 miles an hour. I mean, that's not small. Okay, a second later, I'm gonna have lost 9.8 meters per second of my speed. That's 19.6 meters per second. A second later, I'll have lost another 9.8 meters per second of my speed. And at 3 seconds, I'll have lost all of my speed. I'll be at 0 meters per second. Now, I want to point out that my acceleration is always negative 9.8 meters per second squared. Even here, right here, I'm just transitioning between heading upward and heading downward. This is the maximum height, because it's the last place that I have a positive velocity. It's right before this. This is the turning point in between positive velocity and negative velocity. If I go for another second, now I'm just falling. Negative 9.8 meters per second squared. I'm headed downward. Or sorry, meters per second. I'm headed downward again. And I'm headed downward another 9.8 meters per second. And you can see I'm just falling faster and faster. That's all we're going for. Now, all of our equations that we used before, V equals VO plus AT, T equals VOT plus 1/2 AT squared, V squared equals VO squared plus 2AD, and D equals 1. I like the way Mr. Ward wrote this, V plus VO times T. Or there's the other way, there's V plus VO over 2 times T. They're both the same thing. Okay. It's actually pretty nice. Those all count, but now we always know the acceleration is negative 9.8 meters per second squared. I want to point out that this value is true whether you're headed up or headed down. It's always going to be the same. Okay. So that's the only difference in the problems. So let's try a couple practice problems, see how we're doing. Okay. I think we are. I was going to say, I need to actually stop here and start a new video. So we'll play the next video in a second.